Hello folks, in this video tutorial series we'll talk about the architecture of a proactive security tool. Now the very basic question, what does a proactive tool do? Till now we have actually classified all the tools we've made into either sniffers which sniff packets from the network and displays some of those data onto the user screen, or as injectors, that is programs which inject packet onto the networks. So now the most logical step is to combine both of these and harness the power of both. So a tool which actually makes dynamic decisions at runtime based on the information collected from the network may be called a proactive security tool. The basic funda is simple: sniff, decide on the basis of the sniffing what you want to do, and then go ahead and inject the appropriate packets. So logically such a tool can be divided into three parts. The first is the sniffing logic, second is the injection logic, and what lies between both of them is the decision logic, which actually takes the decision and then instructs the injector. Now another fundamental thing to such a tool would be the communication mechanism between all these three logic, and that is accomplished by means of IPC. IPC, or inter-process communication, may be in the form of named pipes or message queues, shared memory, etc., etc. The bottom line is that this is as cool a tool can get. So now quickly let's look at the architecture of a proactive security tool. Now the first thing which such a tool would do is create the sniffer thread and then the injector thread. As you can see, main is the function which gets initialized when the program is executed, and from there on first we create the sniffer thread and then we create the injector thread. Then the sniffer starts sniffing packets from the network, and once this is done it sends its inputs from the sniff data to the decision making process. The decision making process decides what to do based upon what it sees on the network and sends out the output of the decision to the injector. The injector now injects the appropriate packets onto the network. Once again there would be a feedback, and because of the injection something would happen which would be sniffed by the sniffer, and this input would go to the decision making process, which would once again instruct the injector to inject appropriate packets. So as we can see that there is some sort of a feedback loop which is going back from the injection to the sniffing, and the decision process takes notice of this feedback and decides what to do next. So actually the tool is now intelligent. It understands what's happening on the network and based upon that decides what to do next. Now breaking this up into various steps, first of all is creation of the sniffer thread, then creation of the injector thread. Then of course we have to sniff packets onto the network and send the inputs based upon whatever we've collected as information from the sniffing phase to the decision module. The decision module sends output to the injector, which in turn goes ahead and inject packets. Once again we go back to step 3, sniff the packets based upon what we have injected right now, and then try and decide what to do next. So basically 7 is nothing but pointing to the feedback loop. Now the point is, what do we require to know programmatically in order to create such a tool? To create the sniffer and injector threads we require a little knowledge about multi-threaded programming. For sniffing and injection we need to know how to sniff and inject using raw sockets, and then finally to make the decision and then to decide what to do next we typically need a decision module which would communicate using IPC between the sniffer and the injector threads. So the first thing was multi-threading. Now of course I cannot present to you a very detailed multi-threading tutorial here, so I'll just tell you a little bit about what multi-threading is and end with a link here which has a more comprehensive tutorial on multi-threading. So threads are nothing but lightweight processes. What this actually means that they have their own local variables and their own stack, but The global variables, the heap, everything is shared with the main program itself and between all other threads which are created. The basic advantage of threads is that threads run concurrently along with the parent thread, which is the main function. We'll be using POSIX threads in all our programming exercises, and we'll also be just concentrating on two simple POSIX thread APIs, the first of which is pthread_create. What this does is it creates a thread. It actually takes the function which should be made as a thread and an argument which should be passed to that function as input. Then the other API which we will use is called pthread_join. This is a way by which the parent can actually wait for the daughter threads to finish execution. What this means